viruses.
Recording in progress.
Now, what happened, which was so unique, is that when the FDA was discussing authorizing first-line responders and healthcare professionals to use ultraviolet light, there was only a handful. There was only 2 or 3 studies that were actually done to show that UV's ability to actually neutralize and disinfect and extend the life of N95. And it just so happened that this study that was sponsored by the FDA, that was published in the American Journal of Infection Control, happened to be Fresh-aire UV systems that were used. So at the beginning of the pandemic, when there was just such a run on N95 and respirators and PPE, not only was Fresh-aire UV put in a position to address our HVAC customers, but we were also put in a unique position to address our first-line responders, those healthcare professionals, those technicians, and those doctors and nurses that needed to have N95 in order to do their job. Now, thankfully, those days are behind us and there's no issue as far as supply for N95s, but this lends itself to really moving the ultraviolet technology forward. Now, Fresh-aire UV has been manufacturing UV systems for 20 years. And since 2001, we have over 2 million systems installed worldwide, and by the end of this year, it will be 3 million. We are known for our robust nature, the engineering systems that we manufacture, designed for residential, designed for commercial, designed for healthcare, multiple innovative patents, and a robust lifetime warranty. So one of the things that we're known for is that our systems are going to last a lifetime. And we are very, very proud of that fact. The last thing we want is to have a failure in the field. So certainly, 30, 40 years ago, we did not need a Fresh-aire UV system. Our buildings were loose enough as it was. We were naturally bringing in fresh outside air to dilute the concentration of biologicals, chemicals, odors, and VOCs that were trapped within the envelope of the home or the building. Well, things have changed. Before COVID, putting COVID aside, we were not doing enough. We are not doing enough to bring in fresh outside air to dilute the concentration of contaminants that are trapped within the envelope of the building. Some would argue that the reason why there's such a rise in allergy and asthma-related illnesses is because we're insulating ourselves like never before. The air inside of our homes and buildings are up to 100 times more polluted than outside. We should be opening our doors. We should be opening our windows. We should be bringing in fresh outside air to dilute the concentration of biologicals and chemicals and odors that are trapped within our buildings. But in doing so, we are losing resources. We want to save money. We want to save energy. We want to save resources. So we're insulating ourselves like never before. So of course we have filters, and filters are designed to attract and capture particulates. And if we were to look at a cross-section of those contaminants that you and I breathe on a daily basis inside of our homes and buildings, 35% of those contaminants are trapped on the filter. 65% of the contaminants that we breathe, the bacteria, the viruses, the mold, the chemicals, the odors, the VOCs, they pass through a filter like sand through a tennis racket. We call that the other 2/3. So it really is having that strategy. It's a layered strategy. We use filtration to capture the particles, and we use a UV and carbon system to address the biologicals, odors, and VOCs. Let us not forget that the filter's primary purpose is not to improve the air quality for the occupants, it's to protect the equipment. If we did not have filters, the equipment would essentially fail because of particles that would cause the equipment to lose efficiency and ultimately stop working. But of course, if we're removing those particles in the air that you and I would breathe, it is an air quality product. So it really is a strategy of implementing and complementing these different technologies, where one is designed for particulates and the other one is designed for biologicals, odors, and VOCs. It's part of a complete IAQ solution. So to recap, we're using UVC light to address the viruses, the bacteria, the mold, the microorganisms. We're using PCO and carbon technology for odors and VOCs. And of course, we're relying on filtration for particulate removal. Now, I always enjoy talking about ultraviolet light because there's just been so much information in the media. There's been also a lot of misinformation. So I like to discuss the fundamentals of UV and hopefully empower you to understand more of what UV can and cannot do. So if I had a UV camera and I took a picture of the sun, it'd be a fierce blue or purple. That's because the sun produces all UV wavelengths of light: UVA, UVB, UVC, and UVB. Now, we're very aware of UVA and UVB. Our sunscreen, our sunglasses, the front window of your car is all designed to filter out that UVA and UVB light. Now, as dangerous as we perceive UVA and UVB to be, it actually has very little germicidal power. And a good example of that is a sunburn. One sunburn for anybody won't be an issue, but continually abusing the sun over the course of someone's life has the accumulation of enough ultraviolet to the point of mutation, which presents itself as skin cancer. That's the fundamental process of ultraviolet disinfection. It's delivering over a period of time that lethal dosage of ultraviolet to the point of mutation. Now, unlike UVA and UVB, UVC has a lot of germicidal power. Now, we produce the UVC light at the 254 nanometer wavelength. UVC never makes it down to ground level from the sun. It's absorbed by the ozone layer. So when we talk about the importance of the ozone layer, why it's so important not to have a hole in the ozone layer or a thinning of the ozone layer, if that should ever happen, it would allow the UVC light to penetrate down to ground level, and it will essentially kill all living organisms on the planet. That's how powerful UVC light is. A fourth wavelength called UVV, or vacuum UV, is an ozone producing wavelength at 185 nanometer. We do not produce the 185 nanometer wavelength. We do not produce ozone. We are specifically producing the non-ozone germicidal wavelength of UVC at the 254 nanometer wavelength. So if I was to recap, the UVC light is invisible. That is in the invisible spectrum. When we see light with our eyes, the visible spectrum from blue to red, from 400 to 700 nanometers, that's what we all see. And in the invisible spectrum is where the UVC light lies. Now, UV's been used for well over 100 years. It's been well adopted, well understood, well tested, well validated. The funny thing is back in the 30s and 40s, hospitals used to use UV in all kinds of innovative manners. They used to use it in HVAC, they used to use it in ductwork, they used to use it in room. I've seen antique Westinghouse UV induct systems, big, heavy cast iron control boxes with big, thick UV tubes. Looks very much like the UVC systems today. The science was sound, and hospitals used UV for decades until the 60s and 70s, when antibiotics became readily available, and hospitals pulled back on using UVC disinfection. If a patient gets sick, well, they'll take some antibiotics and they'll be okay. Now, about 15 years ago, we started to see a real increase in HAIs, hospital-associated infections. These are pathogens that are resistant to antibiotics, costing the healthcare industry tens of billions of dollars every year in uninsurable costs. So hospitals were looking at ways to treat and address HAIs, because if someone gets sick, those antibiotics may not necessarily be effective. MRSA, VRE, C. diff, these are just a few of the examples of these superbugs that are resistant to antibiotics. So hospitals have readopted ultraviolet over the last decade or so, using UV in all kinds of innovative manners inside HVAC, inside ductwork, inside rooms. You see there is our ceiling tile mount unit for unoccupied spaces. There's even UV robots that autonomously move around the room, disinfecting high-touch spaces. Now, certainly UV's come a long way, and with COVID-19, it's just moved it that much further ahead. So ultraviolet light, although it's been gaining in popularity over the last decade, what has happened in the last year and a half is incredible. It's been understood and validated and tested and employed in so many applications over the last decade or so, and became so popular. But what has happened last year is just unbelievable, how UV's really become the real tool to address the virus. So how does ultraviolet work? Well, UVC light has the ability to penetrate through the cellular membrane and scramble the DNA or the RNA of the microorganism. Same way as if I was to take a hammer to a zipper and I was to strike it very hard and damage the teeth of the zipper, you could no longer zip up the jacket. Well, UVC light works exactly the same way. By scrambling the DNA or the RNA, we could effectively kill, neutralize, sterilize the microorganism. And in the case of a bacteria, in the case of SARS-CoV-2, it would, address the RNA. And we are taking that UV light and we're addressing it and employing it and delivering it to the HVAC equipment, to the air handler, to the ductwork, and to surfaces. And the nice thing about ultraviolet light is that it's completely proven, tested, and validated. We know exactly how much UV we have to deliver to effectively neutralize any microorganism. And this is an example of just that. Every biological has a certain dosage requirement for neutralization. For this presentation here, we are looking at dosage numbers. They're called microwatts. It's like horsepower to a car. It's the power of the UV light. It could be in millijoules or microjoules, but this is in microwatts. But it gives you an understanding of how different biological targets have different dosage requirements for neutralization. An example would be Legionella. We all know about Legionella. It certainly is prevalent in stagnant water. Drain pan would be a great example of that. And Legionella requires around 3,000 microwatts to neutralize. On the other side of the chart, under molds, you will find Aspergillus niger. Now, Aspergillus niger is the most difficult to treat of all spores with ultraviolet, requiring 330,000 microwatts. So we're very aware and very cognizant of how much UV we have to deliver in order to effectively neutralize a very weak bacteria or a very resilient spore. And the calculations that we use certainly is time times intensity. The more time that target has in contact with the UV light, the more UV could be delivered, resulting in a much higher kill rate. The more intense the UV source over that time function, the more UV can be delivered, the higher the kill rate. So our software will certainly take into account the time function, the intensity of the lamp, as well as whatever dosage requirement is needed in order to neutralize the virus, bacteria, or spore. But what's lucky for ultraviolet is typically in the world of microorganisms, when we're talking about airstream disinfection, we're typically looking at bacteria and viruses. And in the grand scheme of things, bacteria and viruses are pretty weak when it comes to ultraviolet. And when we look at molds and funguses that are more resistant to ultraviolet, requiring those high dosage requirements, well, they're pretty much not necessarily airborne. They're thriving on surfaces inside the air handling unit. So when we want to address Aspergillus niger, for example, well, we have a UV light mounted in the air handling unit, disinfecting the drain pan and the coil surfaces. Yes, it does require 330,000 microwatts, but that's actually per second. So with every second, with every minute, with every hour that passes, there's an accumulation of ultraviolet in the millions. And in the case of airstream disinfection, we don't have those minutes. We barely even have seconds. But lucky for us, those dosage requirements are very, very low. Now, the question that we were asked at the beginning of the pandemic, what is the dosage requirement for SARS-CoV-2? Well, happy to say it's not very difficult to neutralize, as I touched on, requiring 3.7 millijoules or 3,700 microwatts. So just about as resistant or as easy to neutralize as Legionella. Now, this is a test I've done hundreds of times, one I always enjoy doing. Oftentimes I'm visiting facilities, could be a school, could be a healthcare facility, and I meet with the facility director. And we have a frank conversation about their nature of their air handling unit, what they may have as far as growing inside their air handlers. And oftentimes they're very proud of the HVAC equipment, and they take me to see the facility, and they take me to see the air handling unit. They turn it off. We walk inside, and yes, the air handler itself, the coil may look clean, but that's either the leading or leading edge of the evaporator coil. It's the tip of the iceberg, so to speak. The majority of the surface area, which we don't see, which is like an iceberg below the waterline, is what's growing and what's typically foul. So I asked permission, would you mind if we take 2 discs and we do a surface test? Now, what's nice about these contact plates is that the gelatin is bowed. So I'm able to take the gelatin, the disc, and press it into the coil. The fins of the coil slice into the gelatin, and I cap both discs. I give one to the facility director, and I take one back with me. You put it in a dark drawer for 3 or 4 days, and then I give the facility director a call, David. I call up David. I said, David, have you had a chance to take a look at the discs? And for whatever reason, they always forget that they did this test. So surprisingly enough, he goes, Aaron, let me go get it. I'll be right back. He comes back and he's silent. And I know what he's looking at because we did 2 tests and I kept 1 disc for myself. So I know what's growing on his coil in his petri dish. He says, Aaron, I can't believe what I'm looking at. It's mold, fungus, slime. It is so contaminated, it's not to believe. And I explained to David that the reason why that's the case is that when you look at the coil, it looks clean, but that's not indicative of the condition of the coil. Now, we have a pretty robust residential line, and we do a lot of residential work. And most of the testimonials we get at Fresh-aire UV from customers are from our residential customers, from homeowners. And some of the most common testimonials we get, it's always been the case, after an installation of one of our units is, I've not slept this well in 20 years. We don't know why we wake up congested, a cough, a slight tickle in our throat, a stuffy nose, or runny nose. Studies show that the air inside of our homes and buildings is directly correlated to the condition of the HVAC equipment. And I would argue that the microbial blow-off from the coil is affecting us in many different ways: headaches, congestion, and a cough. So I go back to David and we put a UV system inside his air handling unit, inside of his coil, and we shine it for a day, for 2 days, for 3 days. And we go back and we do a post test and we wait another 3 or 4 days. And there's nothing growing on that disc, on that contact plate. UV is exceptionally effective at neutralizing and addressing microorganisms. And if there's one thing that we learned here tonight, for you this morning, for me this evening, is that the coil should never go unaddressed. It's exciting to talk about airborne viral neutralization. SARS-CoV-2 is at top of our mind, no question about it. But the UV industry and Fresh-aire UV has been doing exceptionally well over the last decade, addressing the HVAC equipment and ductwork long before COVID. And the air conditioning system itself and the evaporator coil and the condensation of microbial load should always be addressed. So if you're ever able to install a UV system, make sure you install it over the coil or in the air handling unit so you can disinfect the HVAC equipment itself. So a lot has happened over the last 2 decades with ultraviolet and HVAC, but nothing more exciting than 2008 when ASHRAE included UV in their handbook, Ultraviolet Lamp Systems for Air and Surface. There's been about a dozen or so chapters in ultraviolet. I myself am a voting member on TC 2.9, the ASHRAE committee for ultraviolet. I'm also the programs chair for 2.9. So I'm intimately involved with ASHRAE. We are doing exciting things with ultraviolet. We have programs every single year. We have multiple programs every year in ultraviolet. As a matter of fact, the epidemic task force that ASHRAE really, put together to address, HVAC-related COVID issues, ultraviolet played a huge part in the epidemic task force strategies, along with filtration. The CDC highly embraces UV, the GSA, the General Service Administration, the government entity in the US that mandates all new government buildings mandates UV for their coils, as well as Green Build and Well Building Standards, which are associations and standards that have embraced UV as well. Now, the CDC has just updated their strategy, their recommendations for filtration, for ventilation, for schools and childcare. And it really is a layered strategy, as they call it. They are really embracing 3 specific technologies to address the air inside of our facilities. It's ventilation, filtration, and UVC disinfection. So when you have associations such as ASHRAE and the CDC that are really promoting the benefits of ultraviolet technology, we know we've come to a different place. Certainly, the technology has really come onto its own over the past year. Now, we've been doing UV for healthcare for decades. And essentially what we want to do for schools and shopping malls and office buildings is what we've been doing for healthcare for all these years, is try to control the spread. That's essentially what it is. We want to control the viral pathogens and the bacteria and the contaminants that continually recirculate through the HVAC system. So that brings us to our first product category, which is UV lights for the coil. These are our AHU series. These are UV systems that are they are energized. So you have multiple lamps energized by a power supply. The power supply is auto sensing 110 to 277. We have multiple lamp options, 1 year and 2 year lamps, and they come with magnet mounts. A very, very robust unit. Even though it's one of our most standard basic products, we make sure that the systems are built exceptionally tough, very robust. That's why we can offer a lifetime guarantee on these products. The plugs are IP68 rated. They are watertight. You would never have an air handling unit mounted with as many UV lights as you see there, but it gives you an example of all the different locations you can mount the UV light inside an air handling unit. So very, very refined, easy to use, easy to install UV solution for the HVAC equipment. This has been an industry that has really been hit hard by COVID, hospitality. And hospitality is looking for ways to really put their guests' mind at ease, to do more for their guests, so they know that the hotel is doing the most they could possibly do for the health and well-being of the guest in their guest room. Long before COVID, I certainly stayed at my share of hotels, and I can't tell you how many PTACs and terminal fan coil units I wished had a UV light installed inside the system. That musty, mildewy smell that we all know about that gets blown out of the PTAC could be addressed with UV. So hotels and hospitality have really, really been a huge driver for us over the past 6 months. When a hotel is looking to install UV in their guest rooms, it's not for 1, 2, or 3 units, it's for hundreds at a time. So these are small format UV lights with a reflector shield and a magnet mount, different voltage options with this very small power supply. And these are what we call tight fit kits. And they can be positioned in all kinds of unique orientations in very small, tight, confined spaces. Perfect for PTAC, fan coil, and terminal units. And one where they're often used in hospitality, of course, dormitories, army barracks. So a real unique way to keep the HVAC equipment once again sterile and clean, which is so important, as well as continually disinfect the air as the air continually recirculates through the HVAC equipment itself. We've really been put on the map with this product here, our Hvac. The Hvac is a UV system with a carbon wing. It's actually a carbon catalyst that has a lifetime carbon cell. So there's nothing to replace except a UV lamp every 3 years. Now, Hvac has brought us a lot of notoriety. As a matter of fact, 2 months ago, we appeared on Good Morning America. There was a school that outfitted all their air handlers with our Hvac product. And certainly a great product, one that has been tested against SARS-CoV-2, and one that not only addresses obviously the HVAC equipment itself, but the air as well. Available multiple voltage options, low voltage, 24 volt, as well as high voltage, 110 to 277, lifetime guarantee, lifetime performance guarantee, zero ozone producing. And it really is a refined product that's able to address probably systems up to 5 tons. So this is a very good residential and small commercial, light commercial product. Great for dog veterinarian clinics, dog kennels, dentist's office, things of that nature. Now, we do a lot of work with convenience stores, gas stations, restaurants for their ice machines. And this is always a very unique product to talk about and one that's really interesting. Now, in North America, we're installed in some of North America's largest gas retailers, and they put our UV systems in their ice machines for their concession area. And before they move forward and outfitted all their ice machines with Fresh-aire UV Ice UV, they want to see how effective our systems were on the ice machine. So they brought in 2 brand new ice machines. One they fit with our Ice UV, that's the ice machine with the blue outline, and one they did not. And after 10 months of operation, it was the big test. Let's see how effective this UV light was in the machines that with and without the UV light. Now, the ice machine that did not have the UV light, the green outline after 10 months, it looks visibly, we call it slime, it's microbial contaminants, it's mold and fungus, and it looks pretty contaminated. The one without the, with the UV light, I should say, looks clean. NBC in the US did a segment, America, what is the most contaminated thing you touch on a regular basis? And it wasn't necessarily the segment that really caught my attention. It was the fact that they were using what is called an ATP tester to do the testing, the same ATP tester I use. And if you're not familiar with an ATP tester, it looks like an ohm meter with a Q-tip. And you take that Q-tip and you swab down a surface, and then you put into the ATP tester itself, and it gives you a numerical value called an RLU, a relative light unit. The higher the number, the more contaminated something is. It's measuring proteins. And this NBC segment, where they traveled across the US from coast to coast, swabbing down toilet seats, doorknobs, buttons on elevators, handrails. And they said, America, the results are in. The most contaminated thing you could touch on a daily basis, worse than a toilet seat, worse than a doorknob, worse than an elevator push button, is the backseat of a Chicago taxi cab. That was the most contaminated thing they could have tested in their test study across the US. And it measured 4,000 RLUs. And they made such a big deal about the 4,000 RLUs for the backseat of the Chicago taxi cab. Well, I'm laughing because I know full well that this ice machine measures 8,009 RLUs. This ice machine is twice as contaminated as the worst possible thing they possibly could have tested over the course of that test in the United States. And that's indicative of what's happening. Anytime you have a cool, damp, wet environment, you're gonna have microbial load. And the ice machine that had the UV light measured 8,009 to 2. So this is indicative of what's happening inside the ice machine, but also what's happening inside the HVAC equipment itself. Now, certainly, we have the HVAC coils that have very tight packed fins. And after commissioning, immediately after commissioning the HVAC equipment, you start getting biofilm. It starts microscopic, it starts insulating the fins of the coil. You start having heat transfer loss. There's static pressure issues because the air has to pass through those fins of the coil that are slowly getting insulated and plugged up by the biofilm. The particles that make it past the filter get embedded on the biofilm, almost like an adhesive. There's wear and tear on the system. The user wants the temperature at a certain set point. The system has to work harder. It is costing real money to drive the HVAC equipment, not even taking into consideration the microbial load and the odors and the contaminants that get blown off the HVAC equipment back into the building or home. It is a huge issue. So certainly, as I've touched on already, you take a UV system and you mount it inside the air handling unit, and not only are you going to improve heat transfer, you're going to improve the airflow, reduce static pressure, reduce wear and tear, control that odor that they often call dirty sock syndrome, and of course, disinfect the air as the air recirculates. It's best practices to have a UV system mounted inside the air handling section so you could address the HVAC equipment itself, the drain pan, the coil, and of course, the air. Now, the question I get often asked is, do we clean the coil first and mount the UV system? Well, that would be best practices, but that's not usually the case. And this is an example of just that. This is a pretty foul coil. This is 327,000 CFUs of bacteria and fungus. And this is pretty foul. Mounted the UV system, came back a few weeks later, and from 327,000, we're down to 2. That's a 5 log reduction. That's a 99.999% reduction in microbial contamination on that coil. The reason why researchers, doctors, scientists have embraced UV technology is because it is a mathematical certainty that if we do our calculations right and we deliver that lethal dosage, we are going to neutralize that biological target. You saw the chart that I showed you earlier with all the dosage numbers. Well, that is already defined. I could do this 100 times and it's always going to be the same. It is validated, vetted, and tested. And that's something you can't really say with very many IAQ technologies. So the question is, which is the right strategy? Now, there's really two types of HVAC UV applications. There's air handler coil mount, which I've touched on numerous times this morning for you, and there's duct mount. And the question always remains is, well, what is the right application for me and my customers? Well, to understand which is the right solution, we have to understand what is the practical application. And I really like to look at three different scenarios. And it really is about recirculation. Now, if we're contacted by a hospital and there's an operating room, for example, chances are they're bringing in 100% makeup air. There's no recirculation. And if you recall back to my earlier example, when we were talking about the fundamentals of UV technology, we're talking about sunburns, how one sunburn is not going to be an issue for anybody, but continually abusing the sun with enough sunburns have the accumulation of UV to the point of mutation, which presents itself as skin cancer. Well, for a hospital with 100% makeup air, there's no second, third, fourth sunburn. We have to deliver that lethal sunburn, that lethal dosage on one pass. So for those very low recirculation rate applications, for those applications that need to have a very high level, high log reduction on the moving air, we typically will specify the parallel duct mount that you see there at the bottom of the page. Now that is a system that has multiple lamps. It could be 2 lamps, 4 lamps, 6 lamps. They could range from 18 inches to 60 inches. Essentially, it creates a field of UV in the ductwork that as the contaminant passes through this field, there's an extended amount of contact or dwell time between the UV field and the contaminant. If the duct is very large or if the air is moving very fast, we might need 2 of these in series or in parallel. But the design of the system is to deliver the most possible UV irradiance over the shortest period of time. And these types of systems are our go-to solution, our strategy for those applications that require very high log reduction with very low recirculation. Now, unlike an operating room that might be bringing in 100% makeup air with no recirculation, schools, office buildings, shopping malls, your residential home, well, they're a closed system. Typically, we're looking at between 4 and 6 air recirculation rates an hour. So now, comparatively speaking to a hospital with 100% makeup air, we don't need as much UV because we have that second, third, fourth sunburn as the air recirculates through the UV system itself. So for schools and shopping malls and office buildings, we could put a duct mount unit. There's no problem, and plenty do. But the real advantageous strategy for a facility like that is putting the UV lights in the air handling section. Enjoy all those benefits by having a cleaner, sterile coil, not having the coil be a source of biological fouling and contaminants. Keep it clean and continually disinfect the air as the air passes through the air handling unit. Now, if this was before COVID, typically, if we're doing coil disinfection, it'd be 1 lamp every 30 or 40 inches. In this example, you see there's 4 lamps. So what we do now is for those coil mount applications that want to get a higher level airstream disinfection, we will put 1 lamp every 10 to 15 inches. So we will put more lamps to compensate for the fact that the air is moving perpendicular over the lamp, right? We're not getting the same dwell time as a duct mount, but with enough UV, we are able to achieve the same neutralization. And of course, the third application is agriculture. And agriculture could be up to 50 air recirculation rates. There's a lot of moisture, humidity, and CO2 levels. They have to recirculate the air. So comparatively speaking to office buildings and operating rooms, we could use even less ultraviolet. So it really is an understanding of what the customer is enjoying. What are the needs of that customer? A need of a hospital is going to be different than a need of a school. I was actually interviewed for a journal, probably about a year ago now. And they said, they asked me, Aaron, what's going to be the mistake that engineers and contractors are going to make when sizing for ultraviolet? And my answer was, everyone's going to be looking for critical care air quality. Everyone's going to want hospital grade. Schools are going to want hospital grade, and shopping malls are going to want hospital grade. And the fact of the matter is they don't need hospital grade. Their systems are recirculating the air, and we don't have to go to that level of disinfection. We could wait for the air to dilute the concentration of contaminants. It's all about dilution, right? We want to dilute the number of pathogens in the air, and UV in the air handling unit will achieve that. So our UV systems for coil mount is really simple. We try to keep it simple. A lot of our competitors use very, very elaborate metalwork, unistrut, racking. The freight cost alone could be more expensive than the lamps and power supplies. We don't want to go down that road. We try to make things so easy that we're even using magnets in the example you see there. So our UV system uses 12-inch brackets. They get mounted to the frame of the coil or the wall of the air handler. And we also use magnet mounts to hold or position the lamps as well. A very, very easy, refined, simple installation. Very, very, very simple. Our systems are modular. They range in length from 18-inch lamps to 60-inch lamps. They are able to be installed in the smallest rooftop to the largest walk-in air handling system. Our power supplies are 110 to 277 auto sensing. The systems are held in place by magnets or half-inch EMT metalwork conduit. The systems are tied in through a safety interlock switch on the door. So should a door open up during operation, it'll turn off the UV systems. It is a perfect complement to filtration, having the UV systems positioned as you see there, while improving HVAC equipment efficiency. Now, we do have a lot of different options available, but 95% of the installations that we do is simply the example in the top left corner, the power supplies with the lamp. It's all kitted together. It all comes together with a safety interlock switch. That's all that's needed. But some applications want something unique. So some might want reflectors. We have that. We even have our control options, our control box that have a UV sensor called a radiometer incorporated into the system itself. For bioterrorism applications, for example, they want to guarantee, it's a very sensitive application. They want to guarantee that the level of UV doesn't fall below a predetermined level. And should that happen, it'll notify the system through BMS, Audible, and other alarms that there is an issue with the lamps. So we do have a la carte options that are designed to complement the installation, but for the most part, most of our installs are the power supply and the UV lamp. For those customers that are looking for that higher level air disinfection, that parallel orientation to ductwork that we discussed, we have our ADS system. These are, as I mentioned, 2, 4, or 6 lamps mounted in a parallel orientation to airflow, and they are designed to treat and disinfect. And we're going to touch on very shortly how we size our systems. But first, we do use obviously UVC lamps. It is a UVC disinfection system, but we do use the highest quality, highest output lamps possible. There are a lot of different quality UV lamps in the marketplace. There's soft glass lamps. These are not soft glass. These are pure fused quartz glass lamps, the highest quality lamp you could use. They are non-ozone producing at 254 nanometers. What does dictate performance of a lamp is as a lamp ages, the gas gets polluted. There's a gas mixture, and as the lamp ages, it becomes polluted and the output drops. We incorporate getters, and if you look at the picture of the lamps, the first picture you see is a 1-year lamp, and the 2 other lamps are 2-year lamps. And the 2-year lamps have 2 getter rings incorporated into the lamp that actually is designed to filter out the impurities in the gas. So it allows for a much more stable UV output over the 2-year lifespan. A very unique characteristic of our lamps are the getters. There's also special anti-solarization coatings incorporated into the lamp itself. If you've ever seen UV lamps from about 15 years ago, after about 6 months to a year of operation, you took the lamp out of the HVAC system, the lamp would be mirrored, almost like mirrored sunglasses. Well, this anti-solarization mitigates that. You could take a lamp out of operation after 3 years and you will not have that mirroring effect. So lamps technology have improved over the last few decades, but there are different quality types of lamps. Our lamps are what we call 15mm lamps, and we use that lamp diameter specifically because the lamp stays warmer in the cold airflow, and we want to keep a lamp warm in order to maintain high output. So we make sure we do allow for a lot of higher quality, higher designs, and some very unique nuanced technology in our lamps to allow for a much higher output than would regularly happen with a UV system. Sizing is really simple, as I gave you a little idea there. You know, I mean, for sizing, it's one lamp every 30 to 40 inches coil disinfection. And if we want to really allow for higher level air disinfection, we would put one lamp every 10 to 15 inches. And we do have a very easy matrix cross-reference guide in order to size. You just, line up the width and height of the coil, and it'll tell you how many lamps are required and what length lamps you will need. Now, I did mention it a few times, we have very robust calculation software. We don't need to know every parameter of the HVAC system. Essentially, we need to know the size of the air handler, the CFM, and the duct dimensions. And with that, we will base our calculations on any number of biological targets. I like using Aspergillus niger because, as you recall, it's the hardest of all spores. So if we could neutralize Aspergillus niger in X amount of time, we could do everything else much quicker. But try the scenario, adenovirus, even SARS-CoV-2. When we run our calculation software, we have dozens of targets we could pull from and base our calculations on. And these are two examples of two of our calculation reports. What's incredible here is this tool that allows you to see how effective these systems are going to be before they're even installed, before they're even purchased. This is how understood the technology is, that we could have these simulations in hand before a decision's even made. And what we do is we take those parameters, we take the CFM, we take the duct dimensions, we take the coil dimensions, and we put that into our calculation software. We choose the length of lamp, and we choose the number of lamps, and it gives us the dosage, it gives us the intensity, it gives us the real-time neutralization rate on a single pass or multiple passes. It shows us where the UV is being irradiated. So all the guesswork has essentially been done. This is incredible tools that are used to substantiate and validate a UV installation. And the work that we did at the beginning of the pandemic, doing all those studies, we did over 50 time points and distant points on UV and SARS-CoV-2 that we're able to use that data and incorporate that into our software. The final system we have is our ESDS. This is for ceiling mount disinfection for unoccupied spaces. So as I touched on, hospitals do use this to complement environmental service cleaning. You could give environmental services, the cleaning crew in a hospital, an hour, 2 hours to do whatever they need to do, and they'll still miss more than 50% of their high-touch contact points. So this is a great adjunct to terminal cleaning practices. Now, I did say I'd get back to our engineering and research and development team. I'm very proud, as you heard at the beginning, of all our people, and especially our R&D and engineering, but we have to give them the tools they need in order to do their job properly. And this actually is such an important resource for Fresh-aire UV. This is a certified ASHRAE 52.2 test rate. There's not many of these in the US. They cost upwards of $500,000 US, but it's ours. We have it, it belongs to us, and it allows us to perfect and improve and test and validate. And it's a tool that we use that we could not be happier to have at our engineers' disposal. We have a lot of studies done. We have third party, first party, paid for, independent. We really are proud of what we've been able to accomplish with our test data. We could not have done what we've done in the marketplace if it wasn't for the reports that we have for surface disinfection, air disinfection, from American Journal of Infection Control to our SARS-CoV-2 testing, we have a lot of efficacy in order to really help support our contractor base and the HVAC community. We're often looked upon as experts in our field. We contribute to journals and articles and publications, everything from hospital-associated infections to consumer air purifiers to SARS-CoV-2, recipients of multiple industry awards over the last 2 decades that Fresh-aire UV's been, designing and manufacturing UV disinfection. Appeared in a number of news articles and publications. So we are very, very proud of that fact. Please find us on social media on our LinkedIn and Facebook page. We do post a lot of industry news, a lot of informative information that you may find interesting. And of course, with that, I do thank you very much for joining us this evening, or for me this morning. So I do thank you very much for this opportunity.
Thank you so much, Aaron. I hope it's okay if we could, take your time a little bit more just to answer a few questions on the chat.
Absolutely.
Great. Thank you so much. I know it's late, so we'll try to, get through this quickly. Okay, so one of the questions Alex has been trying to address in the interest of time, a lot of the questions, but, you might be able to, speak a little bit more about some of the concerns raised here. One question came from Mr. Manuel Borromeo. His question was, your systems do not produce ozone. Is there a reason you do not deal with that with ozone when other UV disinfection providers have products that produce both UVC and ozone?
That's a great question. Ozone has really, ozone is an oxidizer. It's an aggressive oxidizer. I would be hard pressed to find any journal, trade publication, health document that would promote that ozone is a benefit for occupied spaces. Ozone is a lung irritant. A decade or 2 ago, it was mildly accepted, somewhat accepted. Now it's not at all. You have California Air Resource Board, you have Health Canada, you have ASHRAE, you have EPA that are all exceptionally negative on any ozone production. Ozone is ideal for unoccupied spaces. So if you have an application that you want to use for oxidation when there's no people in the room or in the building, I'm a big believer in ozone because ozone could penetrate into materials that UVC cannot. But ozone, once again, is a gas, it's an oxidizer. And if it's in a room, then you are breathing it, and it is going to be what is shown to be detrimental to the health and well-being of the occupants. So we could produce ozone if we wanted to. It's a frequency of a lamp. We do have ozone lamps. We use them for exhaust to outside applications. So if we're doing wastewater treatment as an example, and there's noxious odors being exhausted to outside the building, we would put high output ozone lamps in the exhaust ductwork, but we're not concerned about the well-being of the occupants because it's an exhaust duct. But we will not put ozone lamps inside the ductwork that is recirculating air back into the building.
Thanks. Thanks for that clarification, Aaron. And I think, it's a matter of, like solving one problem and creating another one, by introducing ozone, because, that is associated, having ozone in the air is associated with a lot of respiratory diseases as well. So, that's always a concern. Related to that, there was a question that was raised with regards to, proximity. And I could attest to this personally because we have, the mini UV LEDs in our office and all our split type air conditioners, and, no problems whatsoever. And they're like, pretty close to, our staff. I think I'm trying to dig up a picture of our office. Alex is trying to dig that up. We can share that in a little bit, but I'll let Aaron speak to that as well.
Proximity.
Sorry, go ahead. Yeah.
No, when you say proximity in what respect?
like how close they could, because they have concerns about, being too close to, like a mini UV LED, for example. If there are harmful effects.
Well, it depends on, so on the mini LED, which I just realized for some reason I didn't see the mini LED slide when I did the presentation for whatever reason, but we have our mini LED strip, and the mini LED strip is a different frequency of glass than the 254 that we've been discussing here. It's between the 400 and 405 nanometer wavelength. It works on a different principle, completely safe to look at. You have no issues as far as plastic degradation or anything like that. So the mini LED system that we have it works on a different principle, and there's no issue of proximity. Conventional UVC at the 254 nanometer wavelength, that is something you do not want to subject yourself to, but certainly that UVC 254 nanometer wavelength of light is inside the HVAC system and not an issue for occupants.
Thank you for that, Aaron. There's another question here. They were asking, I guess, about the calculation software. I'll answer to that. They were asking if they purchased a product, does it include the UV calculation software? This is actually, something that we do for you, since we are the exclusive distributor and all our dealers have been trained, because, there's a considerable amount of training that has to go into the, the software that does the calculation. So we provide that as a value added service to all our clients, and at no obligation to pay. So when we, do a proposal, when we visit survey your space, we look at your HVAC units, we ask questions, we interview the facilities manager, we automatically have our quotes accompanied by backup documentation, which is provided by this calculation software. So we will provide that for you. The next question here is okay. Any feedback or any insight with regards to far UVC? We've been hearing far UVC a lot, so maybe you want to speak to that, Aaron?
We've been doing a lot of research on far UV 222. We are very interesting. It's very academic. So theoretically, if it's deemed safe for occupants, then it is a very useful tool to disinfect surfaces in a room where there might be occupants. That's the real goal. And that's the benefit of far UV or 222 nanometer, is that you'll get all the benefits of disinfection, but it's safe to occupants. We're not there yet. We're still in the discovery stage of the technology. The problem with 222 is that it requires a substantial amount of power. They are exceptionally costly, and they're very limited in supply and in size, where UVC is available in all kinds of different formats. So on paper, it's exciting. The reality of things, it's nowhere near ready for real implementation. And it has not been certified yet as safe. A byproduct of 222 is ozone. So it has to be properly filtered not to produce ozone. So there's a lot of limitations. But the real truth of the matter is that if we're looking at HVAC disinfection, air handler, coil, duct mount, and so forth, there would really be very little benefit to using far UV or 222 because it is so limited and so expensive. And essentially 254 is just a better fit for that type of application. But in 5 years from now, if 222 does have their certifications and validations for safety for occupants, and this is an area in a building, perfect example is an emergency room. I think having 222 in the ceiling irradiating surfaces in an emergency room would be an exceptional benefit. So we're keeping our eyes open. We have them. We've been doing a lot of testing on it. We're positioning ourselves to be in the right place when the if the technology is approved. But for HVAC, it's not the right tool.
Thanks, Aaron. One of our last few questions. I got this question about food containers. I personally have had some experience because I installed the ESDS. These are the ceiling mounted lights from Fresh-aire UVC, and I installed it in a tiny storage room by my entrance in my condominium unit, and that's where I dump all my groceries because it takes us a while to disinfect each and every item that we bring in from the groceries, and it's been great because it cuts down like our time by like just less than a minute basically. So the question is, will the UVC affect any food and item inside a container that one is trying to disinfect? So I guess that's similar to my application. If I put like a food container there, will it affect the contents of the food container? Maybe you can.
Sure. And what you've been doing, I've been doing also. I made my own disinfection box. So when I come back from the grocery store, I would do the same thing with my UV. I would disinfect my containers. So UV will not penetrate through the container, so will not affect the food, if that's the question. So that's not an issue. Funny enough, UVC, the same wavelength that we use, has been used quite successfully, mind you, in food production, foodstuffs, and for fruits and produce. There is a benefit. I don't necessarily recommend you necessarily doing this, but when there's a fruit or a vegetable, when a fruit and vegetable goes through there's a process that a respiratory process. It ripens, and there is a process called hormesis, where if you shine a UV light, even momentarily, on a tomato, for example, that tomato believes it's being attacked, which it is, by UVC, and it goes into this defense mechanism, a defense mode. And there's studies to show, and there's grocery stores and wholesale distribution that are momentarily flashing their fruits and produce to initiate this hormesis, this reaction, so the tomato, the strawberries, the blueberries last longer because they don't ripen because of this defense mechanism. And what they find is that these fruits and vegetables become superfruits, so to speak, because they have higher antioxidants, and they last long on the shelf because they believe they're being attacked. And by beefing up, so to speak, their defense mechanisms, they become better fruits and produce. So there's a very, very unique, interesting research out there that is irradiating produce with UV light. So I'm not saying that you're going to get super strawberries, but it's not crazy to think that it might actually be beneficial in some capacity.
Okay, thanks, Aaron. Another question is, I know this was something that we also raised, a few months ago, but now I think the data is in. People are wondering, I think I saw a question in the chat box, whether the research data on actual SARS-CoV-2 is available, and that if that could be shared, because I know like other companies would do it with a surrogate, but we're actually, Fresh-aire has done it with an actual SARS-CoV-2 virus testing for that, so it's pretty accurate. So if you could answer that question, please.
Yes, no, we have the testing. It is done. We have a lot of testing actually, because we have a lot of various time points. And as you did mention, this is not on a surrogate. This was on the actual SARS-CoV-2 virus. The real challenge that we had, keeping in mind that we were, I believe, one of the very first companies to able to attain SARS-CoV-2 testing, is that they were not able to do an aerosolized duct test. And that was an issue, because someone would say, well, they want to see how effective these are in duct systems, because essentially our systems are mounted in ductwork. But that was just not a possibility at the time. So that's the reason why, although our systems were done in an enclosure, the enclosure was designed to only turn the UV light on momentarily to simulate the UV light was on. It was like a diaphragm or iris, a shutter, so to speak, that was placed over the virus, and it would open up and close very quickly. and that would be the irradiance time. And that would be designed to simulate the moving air. So we just want to be very, very transparent when we talk about our data, that it's not a duct mount, it's not under airflow, it was surface, but the design of the test was really designed to irradiate the target for a very short amount of time, simulating as if the air was passing through the ductwork and coming in contact with the UV field. So that was the testing that we did. And hopefully, as we move forward through this, we'll be able to acquire real world duct mount air movement testing as well.
Okay, thank you. And one last question, because I promised that I will get you out of here by 11:15 and we're late. So just one last question. There's some concerns about voiding the warranty for installation. I think that was something that you mentioned about the mounting being, magnetic. So it's the least invasive. You don't have to drill holes and whatnot. So maybe if you want to speak about that a little bit more, Aaron.
We're very, very proud, I can say it like that, of the robust nature of our products. I don't think we would be where we are today if we didn't have that warranty. And I mean, one of our very first customers for commercial was a hospital in Canada back in the wow, this goes back to about commercial customers. This is like 18, 19 years ago. And this hospital had dozens. I mean, I think it's like 300 UV systems were installed in the hospital. It was one of our first largest commercial installs. And to this day, from every couple of years, there'll be a failed power supply. I mean, after 300 units, it's not crazy to think that you're going to have a failure here and there. And we still replace the power supplies. It's a lifetime warranty. So I don't believe we would be in the position we are as one of the leading providers of UV systems if we didn't have such a robust product. I wouldn't be so concerned about avoiding our warranty as long as they're wired up properly, meaning that, it's a 110 to 277 volt, you're wiring it up properly. We do have some low voltage units, 24 volt to 32 volt. And certainly if you tie that to 110 volt, you'll cause a failure. So as long as the systems are wired up properly, tied properly, there should be no issues at all. Our magnet mounts and our bracketry makes installation very, very simple. And, air handling manufacturers are very, at one time, maybe they were a little bit standoffish, if I should say, about UV systems. Maybe it wasn't well understood, or they weren't applying the technology. Almost every OEM manufacturer has or does have an option for UV. So it's one of those products now, technologies that are, really intertwined into the HVAC industry. As a matter of fact, a lot of manufacturers are using materials that have UV inhibitors built into it because they know full well that UV is going inside their equipment.
Thank you so much. And with that, we bid you thank you and good night, Aaron. Thank you so much for spending some time with us, your evening, our morning. And if I see some more questions in the chat group, and I would, encourage everyone to send Alex an email. He posted his contact information. He has his number there. Alex is our sales manager for Fresh-aire products here in the Philippines. And, we'd also like to share that, our customers who we've installed Fresh-aire UV in their facility. So we have, PGH Hospital, we have a bunch of residential, places. We also have it in, commercial facilities, Sanicare, for example, and a bunch of other companies. So we could give you a complete list of, our happy list of customers. So with that, I would like to thank everyone who joined us this morning, and we hope that you all have a great weekend. Thanks again so much, Aaron, for your time.
Thank you, everyone. Have a great day.
Take care and have a great weekend.
Thanks.
Thank you, Aaron.